All right, I'll check it out. We'll go. All right. Today we're going to look at laws of logarithms. Logarithms have these amazing properties, and if you have the logarithm of a product, you can convert it to a sum. It ends up being the log base A of A plus the log base A of B. This should be no surprise to you. You've actually done some of it before. For example, if you have x to the fifth, that's what x squared times x to the third is. Everybody agree with that? What are the bases? The bases are x. They're the same, right? And look at here. The bases are a. The bases are the same. Now, what did you do to the exponents? You added them. And same thing here. You were adding. So it's simply a representation of that rule, just in logarithmic form. So in this situation, we have log base A of, anybody know? A minus log base A of B. Thank you, Nicole. And if we have a power to a power, we multiply. So in this situation, we drop the C out front. We get C times the log base A of A. Sweet. Got it. So the first part of your assignment is going to be able to take logarithms that are written with quotients or products or powers, and you're going to write them with no quotients or products or powers at all. So in this situation, we have log of 5 times 3. I want this times to go away. So I do log of 5. Everybody know what I do from there? Plus the log of 3. Cool. The next one, I have the log of 3 plus the log of 4 squared plus the log of 5 to the 6th. But I can't have a power. Put it up front. It says Alex, who brought his A game today. So I got the log of 3 plus 2 log of 4 plus 6 log of 5. So we look at C. I have both a power and I have division going on. Thank you. I won't take it personally. Okay. So the question is, what do we do with that 3? Or do we do with the 4 first or the 7 first? Division. What do we do? Yes, and here's why. We look at order of operations. 4 divided by 7, then you cube it, right? Everybody agree that cube is the last thing that you do? So the cube is the first thing that you undo. So it becomes 3 log of 4 over 7. Which is then 3 log of 4 minus the log of 7? Or is it 3 log of 4 minus 3 log of 7? Which one is it, the top or the bottom? Why? You're cubing both the 4 and the 7. Excellent. You guys brought your A game today, no doubt. It is the bottom one. Next, if I have a square root, what can I write as the power? Very good. It's the 1/2 power. So I can take that 1/2 and drop it out front. 1/2 log base 3 of x squared minus 5. Now, sometimes people want to mess around with this, but look at it. You take something, you square it, then you subtract 5. So subtracting 5 is the last thing I now do in this operation. Do we have a way to undo subtraction? No. So you're done with that. Oh boy, letter E. Where to start, where to start, where to start? Do I deal with the 2 times, or do I deal with the x to the 4th, or do I deal with the division, or do I deal with this thing cubed? Which part do you deal with first? Think, order of operation. I'm hearing parentheses, I'm hearing exponents. Think of order of operation. If I plug something for x, what do you do first? Do you multiply by 2 or take it to the 4th? 4th, then multiply by 2. Then, and I would have x minus 2. I would cube that, and the very last thing I would do would be divide, right? The last thing I would do would be to divide. So that's the first thing we undo. I've got this 3 here. I can drop that out front, right? Do I move the 4 out front, or do I separate the 2 times? Do I move the 4 out front, or do I separate the 2 times? Which one do I do first? Separate 2 times, because the order of operation is x to the 4th, then multiply by 2. So you have to undo that. Natural log of 2 plus the natural log of x to the 4th minus that 3 natural log of x minus 2. And you can see, as you said, move that 4 out front. So natural log of 2 plus 4 natural log of x minus 3 natural log of x minus 2. Not us. What do you think? Goofy. Got it. You will never use this in real life. I promise. You'll never, ever do it. Ever. Right, exactly. All right, last one. We got this natural log of 4x squared over 2yz raised to the 1/3 power. That's my power, right? 1/3? Okay, you take it from there. You try. By the way, a shout out to Caitlin today. We don't see Caitlin in class. We hope you're doing well. Okay, does everybody agree that that's where we start? Now what? Now what's the next step? Undo the division. 1/3 natural log of 4x squared minus 1/3 natural log of 2yz. Everybody get there? Okay, let's look at this guy. Okay, do I move the 2 out front, or do I separate the 4 and the x squared? So 1/3 natural log of 4 plus 1/3 natural log of x squared. I've got to separate these, don't I? Minus 1/3 natural log of 2 minus 1/3 natural log of y minus 1/3 natural log of z. We will talk about that in a second. Last thing I do is I dump the 2 out front here. That's my only power. 1/3 natural log of 4 plus 2/3 natural log of x minus 1/3 natural log of 2 minus 1/3 natural log of y minus 1/3 natural log of z. So Shelby raised a great question. Phenomenal question. Are you ready to deal with it? I am subtracting all of this, right? Everybody agreed? So I'm distributing the subtraction sign through. Now, watch something that's cool. I'm going to try to check my answer because you want to be a great mathematician, always check your answers. Verify, is your answer reasonable or not? We look at it. Does everybody agree that 4 is being taken to the 1/3 power? So look at this. I have a 1/3 in front of the 4. Everybody agree that x is being taken to the 2/3 power? So the x is a 2/3. 2 is being taken to the 1/3 power. Y is being taken to the 1/3 power. Z is being taken to the 1/3 power. Other thing I want to notice is this. X to the 3rd over y to the 5th. Everybody agree that that's x cubed times y to the -5th? That those are the same? That means if something's in the denominator, the exponent is negative. So Shelby sees if they're sitting on the bottom, they better have negative values. And if they're sitting in the numerator, they better have positive values. See that? Pretty cool. Start the front part of your assignment. Go. All right, so we took a single logarithm and we expanded it. Now I'm going to take multiple logarithms and write them as a single logarithm. Hey, I got the log base 2 of 5 plus the log base 2 of 7. I think that's then the log base 2 of 5 times 7, which is sweet. See that? Let's show you some tricks of the trade. Yeah, Carson said we're going to get a squared in here. You're absolutely right. We got 2 log base 5 of 3, but I'm going to write this as minus, and we seem to forget this piece, but dividing by 3 is the same as multiplying by 1/3. So I got 1/3 log base 5 of 64. So as Carson said, we dump this 2 up top. It becomes log base 5 of 9 minus log base 5 of 4. Everybody catch up? Okay, subtraction I write as division 9/4. So it's log base 5 of 9/4. Sweet. What do you think of that, DeWalt? Not a fan. I'm going to take care of the exponents first. You guys help me out. Natural log of what? 16 minus natural log of 8 plus the natural log of root of 2. Thank you, Jada. Now, this is either going to be the natural log of 16 roots of 2 over 8, or it's going to be the natural log of 16 over 8 roots of 2. Which one is it? The one on the left or the one on the right? Are you sure? Which one? Shelby is correct. It's the one on the left. Folks, watch, watch, watch. Positive or negative? Positive or negative? If it's positive, it's going to be in the numerator. If it's negative, it's going to be in the denominator. Got it? Becomes the natural log of 2 roots of 2. Done. Thank you for the sounds. That's good. Next one, 3 times the natural log of. I'm going to see if we can actually see this and put it all together. It's not that bad. What's going to be, no, don't think negative thoughts. Think happy thoughts. What's going to be in the numerator? X plus 1 times x plus 2. What's going to be in the denominator? Y squared. Yes. Exactly. Minus 2 natural log of y. So we agree that that's the natural log of y squared, and it's negative, so it ends up in the denominator. So I can now take the 3 and move it. I get the natural log of x plus 1 times x plus 2 over y squared. I take all of that cubed. Notice I'm not cubing the natural log. I'm just cubing the things I'm taking the natural log of. All right, let's make it really cool now. We can use these properties in order to evaluate expressions more easily. Log base 2 of 32 to what power? 1/2. What could I do with that 1/2? Drop it out front. 1/2 log base 2 of 32. Shoot, I wish I knew what the log base 2 of 32 was. 5. Because 2 times 2 is 4, times 2 is 8, times 2 is 2 to the 5th, right? So we've got 1/2 times 5, which is 5/2. it just, the smart board just, we get to logarithms and it can't handle it. It just shuts down. Yeah. So this is the 1/2. This is 5. Better? The next one, log base 5 of 100 minus log base 5 of 4, that's the log base 5 of 96, right? No. 100 over 4, which is? Yeah, log base 5 of 25. That's what we do. Oh, right, it's a single logarithm. We have to divide those. What's log base 5 of 25? Those. Spanish for 2. Do you see how I got the 25? So I have the log base 5 of 100 minus the log base 5 of 4. So that's going to be the log base 5 of 100 over 4. 100 over 4 is 25. Now this means 5 to what power is 25? Are we better? What could I do for letter C? Put the 4 up front. 4 log base 3 of 27. I wish I knew what log base 3 of 27 was. It's 3. So you get 4 times 3 is, oh man, look at letter D. Like that looks impossible. Thanks for persevering. What could we move? The 3, where's it move? No. You can't move the 3, like this is an exponential. You got to move it from the logarithm. See what I'm saying? So folks, if you have like e squared, you can't drop just the 2 in front there. It doesn't work like that. Right? Yeah, next time you guys do 5 squared, you can be like, well, drop the 2 in front, we get 10. Yeah. You can't do that, right? It's called voodoo math. What I do is I go e to the natural log of 5 cubed. Well, hey, somebody told me something yesterday about e and natural log. They're inverses, so they cancel out, leaving you with, which is 125. So that brings us to our final piece for the day. Log base 6 of 14. We're going to play the guess game. We're going to see how you guys do with it. 6 to what power is 14? You guys lay it on me. What do you got? All right, so we're going 6 raised to the 1.284. Thank you, DeWalt, for your shot. 9.9, not even close. Let me give you another one. 1.5. Ooh. 1.437. 469. 472. Whoa! 1.473. Ooh, pretty close, huh? Would be nice if there's a way we can do it without just guessing. You use a change of base. You do the log of 14 divided by the log of 6. This is important that you see this here. What's the base? 6. What did I change the base to? 10. So our calculator has buttons where we have log base 10. It also has buttons where we have log base E. So you can do on your calculator either log base 10 of 14 over log base 10 of 6, and that will give you the answer. Or you can do natural log of 14 divided by natural log of 6. That will give you the answer. You guys know the answer should be about 1.473, right? You just take out your calculator and go log of 14 divided by log of 6. Boom. Or what you could do is natural log of 14 divided by natural log of 6. Have a great day, folks.